Hello, everyone. We're looking at our next unit, which is all about circles. So we're going to start reviewing a little bit about what are the different parts of a circle, and then reviewing a little bit about circumference. So specifically, what is a circle? Well, like it says, a circle is a group of points that are all equidistant from a fixed point, which is called our center. Now, when we name circles, we have to use a very specific symbol. And that is our circle symbol here. Sorry, I'm going to make that a little bigger. With a dot in the middle. And again, that is our symbol for a circle. And whatever letter is at that symbol, maybe it's a K, that is what we use to name this. So we would call this circle K. Now, once we kind of know how to name the circle, then we can get into the different parts of our circle. And one of those main parts, again, that we've already visited is the radius of a circle. Radius of a circle has to go from the center to the edge of that circle. So when we check out our picture here, let's say we have, again, we'll put our K in the middle. And so again, a radius has to go from the center to the edge of the circle. So let's call that point A. Now a radius is a segment. And so it has to be named as such. So we're going to have segment KA. Now that easily could be reversed, which is fine. We could call it segment AK instead. Either of those are the radius of our circle, because they extend from the center to the edge. Now another big part, again, that we've already kind of looked at is the diameter. Our diameter of a circle has to go all the way across, edge to edge, through the center. So that's kind of our big idea here for a diameter, is that it has to go through the center, edge to edge. So edge of the circle all the way across through the middle. So there's where I pass through the center, and there's my other edge. So let's call this B and a C. And again, we use the edges of the segment to name this. So segment BC, or again, you could reverse it and have segment CB. Those are our those are our diameters. Now, the other special kind of segment that we see inside of our circles is what we call the chord. Again, this one does go edge to edge, but it does not have to pass through the center. It might, but it doesn't have to. It's not its requirement. So when we go back over, let's say we have a segment that extends from B to A. And so that would be considered a chord. So segment BA, again, could be reversed. Segment AB. So again, these are all types of special segments inside our circles. Okay, they're all segments. Now, there are other special things that go on with circles that are not necessarily a segment, such as the arc. So when we look at arcs, they are made up of a part of the edge. Okay, they are a part of that circle's edge, and they have to be measured in a very special way. When we deal with arcs, they're actually measured in degrees, just like our angles are. Okay, they are measured in degrees just like our angles. And they have a little symbol that goes along with them, and that is to draw a little curved piece over the top. That is our symbol for an arc. Now, arcs come in 3 classifications. Okay, one of those classifications is what we call a minor arc, which is less than halfway around the circle. So I'm just going to go with less than halfway. So let's say my arc starts at, let's say A, and extends all the way to C. So I have not gone more than halfway around. I've only gone less than halfway around this circle. And we use the ends to name these minor arcs. So again, we draw our arc, AC. Again, might be reversed, CA. Now, minor arcs can come with 2 letters or 3 letters, depending on how many it passes over. But it's never going to be more than 2. I'm sorry, never going to be more than 3 letters. We'll see some examples in just a minute where we do have some that are 3 letters. But again, they are never more than 3. And you have to use the ending letters. Now, our other type of arc is our major arc. Which is more than halfway around the circle. And this one has to have 3 letters. And those 3 letters tell me the path I have to follow. So let's say we start from B and I go all the way around past A, all the way to C. Now I cannot stop at C because if I do that, I've only gone halfway. So I have to go farther. So let's say we take this other point that's here, and let's say we call that point D. So if I go from B through A, around to C, and then stopping at D, now I've gone more than halfway. So we have to use the B and the D here for our angle, for the arc. The middle letter, you can choose which one you want. So we're going to name this both ways. Again, major arcs must have 3 letters. So we have arc B, A, D. Again, you can reverse those 3 letters, or we could use the C instead and have B, C, D. Okay, but again, with these, you must have 3 letters. Okay, otherwise, if you only have 2, we're going to assume that that's a minor arc. But again, minor arcs could easily have 2 or 3 involved. Okay, minor arcs could have 2 or 3. And again, follow the order of those letters, trace the path. Now, the other special classification that we have is a semicircle, which is exactly halfway around. Okay, exactly halfway around. So if I go back to my picture, that could be the arc that starts at B, goes all the way around through D, and then ends at C. And this one as well has to have 3 letters because I need to know which side of the circle, which half am I going to use? So we could have arc. Let's see, what did we start at? Go back and check the letters. BDC. Now, the nice thing with this one, how do we know when it's exactly half? Well, semicircles have to have ends on a diameter. That's the only way I know for sure that I am exactly halfway, because again, a diameter is halfway across the circle. Diameter cuts it in half. So if I don't know the ends are sitting at a diameter, I do not have a semicircle. I have to have that, to verify that in order to say it's a semicircle. All right, so let's practice naming some things. All right, so we're going to name the circle and identify a radius. Now, there are in fact 3 radius segments in this figure, so we're going to name all 3. All right, when we name the circle, we have to use the center. So my center is the letter P. So when I name this, I have circle P. Now we'll do a radius segments. Way too small. Now, since there are 3 of them, I'm going to use plural. Radii is a plural for radius. And again, they have to come from center to the edge. So we've got P to L, P to N, and then P to M. All 3 of those are radius segments to this circle. And just keep in mind, all radii in a circle are going to be congruent. Because they're all going to be the same length. So just keep that little bit in mind. Because if I know P to L, I also know P to N and P to M. All right, let's try number 2. Identify a chord and a diameter in our circle. So remember, a chord does not have to go through the center, but it might. Because again, a diameter is a special type of chord. But for sure, I can use JK, so segment JK, or I can have segment HG. Those are both chords. But when I go to name the diameter, we can get a little more specific. Because diameters have to pass through the center, which means HG specifically is my diameter. All right, so now that we've kind of talked about some of our parts, let's look at how we can use those radius segments and diameter segments to work through some problems. So some of the radius relationships that we've already seen, we know that the radius is supposed to be half of my diameter. So now we're going to add to that the fact that our radius is also equal to the circumference of a circle divided by 2 pi. So we can use those 2 pieces of information to find out what our radius length is. Again, depending on which one they give me. We also have some relationships when dealing with a diameter. So our diameter, we already know from a previous unit, says that the diameter is equal to 2 times whatever my radius is. So now we can add to that, now that we've kind of worked a little bit with circumference, is that our diameter is equal to your circumference divided by pi. So those are some of our relationships that we've already seen, already worked with. So let's practice again using those relationships and solve a couple of problems. All right, so when we look at number 3, it says QV is equal to 8. So I need to figure out first, is that a radius or is that a diameter? So it's all about where is it in the circle. All right, so Q to V is from center to edge, which makes it a radius. And it says, what is the diameter? So we know that diameter should be 2 times whatever my radius is. So 2 times, well, it says my radius is 8. So 2 times 8. So my diameter has to be 16. Let's try another one. All right, number 4, TU is 14. All right, so T all the way to U goes all the way across through the center of the circle, making it a diameter. And now it wants to know what is the radius. So my radius is again supposed to equal from up above your diameter divide by 2. So my diameter is a 14. And if I divide that by 2, means my diameter, my radius should be 7. Let me fix that as well. So my radius should be 7. All right, now let's see what else we have. Let's try a few more. All right, if QT is 11, so we need to see what is QT. Is it a radius? Is it a diameter? What is it? So QT starts at the center and goes to the edge of my circle, which means it is a radius. Now let's see what QU is. QU is also a radius. So if I know the length of one radius, I know the length of both of them. So that means my QT has to equal QU. So if QT is 11, so is QU. Because again, if one of these segments is an 11, so are the others. If one radius is 11, all the radius segments are 11. All right, last one, and then we'll check out the rest of our formulas here. All right, so similar situation. UT, it says, is 5. All right, so that starts at U, goes all the way across to T, which makes it a diameter. What is the length of VQ? Well, VQ is a radius. Sorry, let me rewrite that. All right, so if I'm looking for the radius, my formula says take your diameter and divide by 2. So if my diameter is 5, then I'm looking at 5 divided by 2. So my radius would have to be 2.5. 5 over 2. All right, so now let's work with our next piece here, which is our circumference formulas. Now, we already know when dealing with circumference that it's supposed to be the distance around the circle's edge. And we've already worked with some formulas in order to find circumference. We've seen 2 of them actually. One of them said that your circumference was equal to 2 times pi times r, or we had one that said your circumference was pi times the diameter, and it just depended on what do they give us. So when we start using these formulas more in depth, there's 2 ways that your answers could come about. One of those first ways is to leave it exact. Now, when we leave things in exact form, when things say exact, that means leave the answer in terms of pi. Which means there better be a pi in your answer. Multiply everything else except the pi. So let's see how that works. So find the exact circumference of circle L. So they've told me that my radius is 5. So my circumference should be 2 times pi times my radius. So 2 times pi times 5. And now the fact that it says exact, leave it in terms of pi. The only numbers we multiply is the 2 and the 5. Those are the only things that we multiply together. So 2 times 5 is a 10. The pi just comes on down. And that is my final answer if it says exact. Okay, exact means do not multiply through the pi. Multiply everything else. Now, number 8, let's try this one. Number 8 this time says find the rounded. So when we have those that say use the rounded or round off to whatever decimal, that means we get to use everything. Or we're going to multiply every piece. We're going to type in everything that the formula says. So in this case, we will multiply by the pi. We'll get that long rounded decimal answer. So let's see what we have. So we have again a radius, which is 2. So my circumference should be 2 times pi times r. So circumference should be about 2 times pi times our radius of 2. When we type all of that in, my circumference is about 12.57, and we are in centimeters. I rounded that off to 2 decimal places. So that is rounded. So you definitely have to read these carefully to see, do we need rounded or do we need exact? Let's try a few more. All right, so this next one says find the circumference of a circle if the radius is 10. It does not say rounded or exact, so we're going to do both. All right, so it does say our radius is 10. So when I use my circumference formula, I have 2 times pi times r. So we're going to plug in that 10. All right, and so we're going to get exact. We'll get that one first. Again, 2 times 10. Multiply everything but pi. So 2 times 10, yes, 2 times 10 gives us a 20. Your pi comes on down. So there's exact. Rounded, we multiply all of it. So my circumference is about 62.83. And we are in inches. And there's my inches for the previous one. So again, just depends. What does it want? Do I need exact? Do I need the rounded? Let's try another. Find the circumference if the diameter is 6.3. We're going to do the same thing we did last time. Diameter is 6.3. We'll do exact and rounded. So this time my formula, since I have the diameter, says pi times diameter. So my exact, well, the diameter is 6.3. So I have 6.3 pi because there is nothing else for me to multiply by. So there's my exact. Now let's do rounded. We need to actually multiply 6.3 times pi. So my circumference is about 19.79, and we were in feet. So again, if it says exact, do not multiply pi. If it says rounded, go ahead and multiply it out. All right. Now let's see if we can work backwards. All right, find the diameter and radius if the circumference is 8 pi. Notice again, there's pi in that answer, pi in that value. So that means that is an exact value. So if I need, let's start with the diameter. It's the bigger one. So if my circumference is 8 pi, the diameter says to take circumference and divide by pi. So I'm going to take that 8 pi and plug it in for circumference. So 8 pi divided by a pi. All right. Now, the nice thing with these solves, especially when they're exact, I have pi over pi, so they cancel out, making my diameter just the 8. Now let's do the radius. Our radius formula says circumference is divided by 2 pi. All right, so my circumference, which is 8 pi divided by 2 pi from the formula, again, the pi's will cancel out. And 8 divided by 2 means my radius is a 4. Now, could you have taken your exact value of diameter 8 and divided that 8 by 2 to get 4? Absolutely. Absolutely. You would get the same answer. Problem happens though when it's not exact. The issue is going to come when it's rounded off. When we use rounded values for circumference, like we have for number 10, this is when we have a problem because we don't have any pi's here that are going to cancel. So this time it says my circumference is 106.4. And again, this is a rounded off answer. So we're going to have to use the 2 separate formulas here, because that means when we find diameter, it's rounded. When I find the radius, it's rounded. So my circumference is about 106.4. So my diameter should be circumference divided by pi. So which is about 106.4 divided by a pi. So my diameter is about 33.87. It's about that. And then we do the same thing with the radius. Our radius should be the circumference divided by 2 pi, which will be about 106.4 divided by 2 pi. So my radius will be about, it should be close to half of that diameter number. But again, we need to use the full formula because that circumference is rounded off. So when I do 106.4 divided by 2 pi, I get about 16.93. And so there are my 2 missing pieces if we ever need to work backwards. Okay, guys, I hope you enjoyed learning a little bit about your circumferences, your radius, diameter segments, and all the different parts and how to name them. Please don't hesitate to reach out if you have any questions at all. Thank you.